All right, so the question is saying that find the derivative of y is equal to x squared plus 2 using the first principle of differentiation. The first principle of differentiation. So write solution. So the first principle of differentiation is defined by the following equation: dy over dx, derivative as h goes to 0, okay, of f of x plus h minus f of x over h. So we can let our y be equal to our f of x, which is going to be x squared plus 2. Then our f of x plus h is going to be, while there is x there, we're going to put x plus h. So where is x, we're going to put x plus h squared plus a 2 there. Then substitute this into this equation. The dy over dx will be equal to the limit as h goes to 0. Then x plus f of x plus h is x plus h squared plus 2 minus f of x is this one, x squared plus 2. That is over h. Everything over h there. And then at this point, you're supposed to substitute what is h, you put 0. But when you do that at this point, you're going to get an indeterminate solution which will be undefined. Which is going to be undefined. So what do? You try to simplify the numerator and see if there will be something that will cancel out. So as h goes to 0, expanding the first term, you get x squared plus 2xh plus h squared plus this 2 minus x squared minus 2. Everything over h. This will be equal to the limit as h goes to 0, then x squared minus x squared to be a 0. So this and this and this will go. Then 2x squared plus h, there's nothing like to this term. Then we have plus h squared, 2 minus 2 to be 0, and then everything over h. So at this point now we can divide this h into that. H into 2xh, we're going to have, as h approaches 0, we're going to have 2x plus h. H into h squared, you remain with 1h. Then at this point, try to substitute if you get an indeterminate solution or not. So where there is h, you're going to put 0. This is just 2x. This is the answer. So you can say that therefore dy over dx is given by 2x. Thank you. Okay, we are looking at a question which is saying that differentiate the given function with respect to x using the first principle. So this is the first principle of differentiation. So first you write your solution, and then the first principle of differentiation, or differentiation by the first principle, is defined by dy dx is equal to the limit as h, which is the difference between the x values, approaches 0. We find the difference between f of x plus h minus f of x, then everything over h. So in our case, we're going to let the y function be equal to f of x, and then we should find f of x plus h will be given by this is our function. This is our new f of x now. So where the x, we're going to put x plus h, so that we can have 1 over x plus h plus 2. Then our f of x is just the given function. You can substitute these into this formula. Substituting that, you obtain your dy over dx will be equal to the limit as h approaches 0 of f of x plus h is 1 over x plus h plus 2 minus f of x is simply 1 over x plus 2, then everything else over h. So at this point, you're supposed to substitute. Where there's h, you substitute, you put 0 to get the limit. But that will give you an indeterminate solution. So what do? Simplify the numerator, or write it as a single fraction. Writing this as a single fraction as h approaches 0 will be given by the lowest common denominator of the two numerators of the two the lowest common denominator of the two denominators here will be the product of the two denominators, which is x plus h plus 2 and x plus 2. Then when x plus h plus 2 goes into this product, you remain with x plus 2. Then x plus 2 times the number which is there, 1, you get x plus 2. Minus, when x plus 2 goes into this product, you remain with x plus h. Then this times the number which is there, you get x plus h plus 2. Then everything divide by this h here, divide by h. Okay, then the limit as h goes to 0, simplifying what is on top here, we have x plus 2. Let's expand this, minus x minus h minus 2, everything over x plus h plus 2, x plus 2 times 1 over h. Reciprocate here when you change from division to multiplication. Then we have limit as h goes to 0, x minus x, to be 0. Okay, then 2 minus 2 to be 0. So you remain with negative h on top over this h times the product down here. We're going to have x plus h plus 2, x plus 2. Then at this point, you can divide out this h here. You can divide out that h, and then we're going to remain with the limit. The limit as h goes to 0 will be negative 1 remain on top, and this will be x plus h plus 2, then x plus 2. X plus 2. This is x plus 2. Then at this point, you can now try to substitute directly. Substituting directly into the given expression. So we're going to put h0 where there is h. You're going to have minus 1 over x plus 0 plus 2. X plus 2. And once you substitute, there's no need to indicate this symbol for the limit. Then from here, this is equal to negative 1 over x plus 2, x plus 2. This is the same as negative 1 over x plus 2 squared. So this is the derivative, of which you can write as, therefore, dy over dx is given by negative 1 over x plus 2 squared. If you like the video, please consider subscribing to my channel, and also click on the like button for this video. Thank you.